Section 10.1, Video Part 2. So this says the hour hand of a clock moves from 2 to 5 o'clock. Through how many degrees does it move? Well, a 2 o'clock picture looks like this, and a 5 o'clock picture looks like this. So the angle we're actually trying to look at is the angle made by the blue and the red right here. Well, do you know anything about a circle? Maybe you know that there are 360 degrees in a circle. Do you know how many degrees there are in each little increment here? Well, there's 12 markings here. If we divide by 12, that means each of these increments is 30. So, how did this move? This moved through 1, 2, 3 of those 30s, which makes 90 degrees. All right, using a protractor. Here's your protractor laid out. Use it to find the measure of angle CAB. CAB is right here, and that lies right on this 20 degrees. Now, when you use this protractor, it's not like the ones you had in geometry. There's only one set of numbers on here. We are starting at the right, going to this vertex, coming back out. That makes 20 degrees. We're also asked to find the measure of angle HAD. Angle HAD is this, which, yes, lands right on that 60, but that's not this angle. Can you tell by the picture? That's a lot bigger than 60. That is an obtuse angle. The 60 refers to this is 60. Do you know how to figure out what this is? Remember, this makes a straight line. The straight line is 180 degrees. This portion over here is 60. So all we have to do is 180 minus 60, which gives us 120 degrees. Here's the same kind of picture. We have a straight line with another angle shooting off this way. We know that this is 28 degrees. What do you know about all of this? I hope you know it adds up to 180 degrees. So if x is 28 degrees, if we subtract 28 from 180, we get 152 degrees for the measure of this big angle that had the question mark on it. Now we want to write an equation. It says use an algebraic equation to find the measures of the two angles described below. Begin by letting x represent the degree measure of the angle's complement. So we will start with x equals the measure of the complement. I'm going to use that to do some translating right here. Complement is what they told me to do for x. This says the measure of the angle. So the angle, whatever it is, because equals is 42 degrees greater than its complement. This is the name of our original angle. This is the name of the complement. What do you know about two angles that are complementary? You know that they add up to 90. So the original angle is 42 plus x. The complement is just x, and we know that adds up to 90. Plain old Algebra 1 kind of equation. Combine your like terms. Subtract 42 from both sides. And 2x is 48. Divide by 2, and x is 24. And x was the measure of the complement, so x is 24 degrees. To find the measure of the other angle, you have two choices. One is plug 24 in for that x right there. 42 plus 24 is 66. Or you could go with the fact that these are complementary, so 90 minus 24 gives us 66. Another picture which they're asking us to find angle 1, 2, and 3. It says x is 21 degrees. Anytime you have a picture and they give you some numbers, fill that into the picture because a lot of times that just makes it so obvious how to do this. You see the little box here, which is telling you that that's a right angle. If that's a right angle, that's a right angle, that's a right angle, all of these would have to be right angles. So, if this is a right angle over here and this is 21, how do we find angle 1? Well, right angle means it's 90 degrees for the whole thing. We will subtract 21 from 90, which is 69. So angle 1 is 69 degrees. Now angle 2 down here is just this big old right angle. So angle 2 is 90 degrees. Now I'm going to erase this to make this a little bit easier to see. Angle 1 is made by those two intersecting lines. And do you notice another angle that's made by those same two intersecting lines? Angle 3. Do you remember that 1 and 3 are vertical angles, and vertical angles are equal? So if angle 1 is 69 degrees, angle 3 is 69 degrees. Here's a picture of a right angle. If you have a right angle and you have two angles that make up this right angle, you should know that the two angles are complementary, which means they add up to 90 degrees. So an equation would be 2x plus 30 plus 3x plus 40 equals 90. Once you have written the equation, it's just an algebra 1 kind of thing. Combine your like terms. That's 5x. 30 plus 40 is 70. That equals 90. Solve by subtracting 70 from both sides. So 5x is 20. Divide by 5. And x is 4. But that's not what they're asking you to fill in. They want you to come up with these measures up here. So once you knew that x was 4, put 4 right here. 2 times 4 is 8, plus 30 is 38 degrees. Put 4 right here. 3 times 4 is 12, plus 40 is 52 degrees. And that checks because 38 plus 52 makes 90, which is what this picture says it should equal because of the box. Now we want to write an algebraic equation to find the measure for these angles. Do you remember that these, made by these intersecting lines, are vertical angles? And do you remember that vertical angles are equal? So my equation is 13x minus 31 equals 9x plus 25. We need to get our x's together, so subtract 9x from both sides to move it to the other side. Gives me 4x minus 31 equals 25. Undo minus 31 by adding 31 to both sides. And we have 4x equals 56. Divide by 4, and x is 14. And like the previous problem, they just don't want x. They want us to plug this back in and do the arithmetic. So this is 13 times 14 for x minus 31. You can use your calculator, and this works out to be 151 degrees. This one better work out to be 151 degrees. These are vertical angles. They're supposed to be equal. But to be safe, especially if you're doing a test, I would check this out. So if you do 9 times 14 plus 25, it is 151 degrees. And because you got this independently of this, and it checks, then you know that you've done this correctly.